Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 35 from the Smith Organic Chemistry textbook. And in this problem, we're asked how many rings and pi bonds are contained in each of these compounds A, B, and C. And we're asked to draw one possible structure for each compound. And so for each, we're given a formula and then a formula after hydrogenation. And so the way to solve this problem is going to be to calculate the hydrogen deficiency index for each of these formulas, and then to look at the hydrogenation data to determine how many of those degrees of unsaturation are due to pi bonds. So for example, for A here, I'll put my answers in green. So to calculate the hydrogen deficiency index, it's going to be 2 times the number of carbons, which in A is 5, plus 2 minus the number of hydrogens, which in A is 8, and then all of that divided by 2. So we have 12 minus 8 is going to be 4 over 2 equals 2. So we know that we have some number of pi bonds and rings that add up to 2. So then when we go and look at the hydrogenation data here, we see that hydrogenating this adds 1 pair of hydrogens. And so we can safely say that one of these degrees of unsaturation is due to a pi bond. So this is going to be 1 pi bond and 1 ring. And so the simplest structure that I can think of with a pi bond and a ring that corresponds to C5H8 is just going to be a cyclopentene. So cyclopentane with a double bond inside of it. So that's A. There are, of course, other structures that you could draw, but that one I think is the simplest. So then looking at B, we're going to do exactly the same thing. So we'll start by calculating the hydrogen deficiency index. So 2 times 10 plus 2 minus 16, all of that over 2 is going to be 22 minus 16 is 6, so 3. Okay, so our HDI is 3 here. Looking at the hydrogenation data, it looks like, again, we add only 1 pair of hydrogens when we hydrogenate. So this is going to be 1 pi bond again, and 2 rings this time. And so something that we could draw that fulfills this formula could be 2 fused 6-membered rings with 1 double bond inside. So there we go. That structure fulfills that formula. So then I'm just going to repeat the exact same thing for C. So the HDI here is going to be 2 times 8 plus 2 minus 8 over 2. So 16, 18, 10, 5. So 5 degrees of unsaturation. However, when we hydrogenate this time, we add 8 hydrogens. So 4 pairs of hydrogens. So this is going to be 4 pi bonds, which leaves 1 ring. And so I think probably the easiest way to satisfy this formula is going to be to draw an 8-membered ring, unfortunately, with 4 pi bonds inside of it. So 8-membered rings are always a pain to draw, but there's a passable one. And there are 4 double bonds inside of it. Okay, and so that's C. And again, I think that the way to approach this problem is to calculate the hydrogen deficiency index for each formula, then use the hydrogenation data to determine how many pi bonds are in each of these molecules, subtract that number of pi bonds from the total HDI to get the number of rings, and then just draw a structure that fulfills all of those requirements. And that's the answer to Chapter 12, problem number